Hello, class. Today we're going to be working on basically absolute value. We had the game yesterday, so today we're going to be working on absolute value. Warm up for today is what is the compound inequality here? We were dealing with this yesterday, so it shouldn't be too bad. We should see that we start at -7 and to -3. So go and give it a go, and we'll continue on here in a moment. Welcome back. So since we're starting at -7, open circle, we should have a -7 is less than x, then x can be no bigger than -3, so we should be writing an inequality just like that. So absolute values, day one, we're just realizing what we have here with absolute values and going from there. Solve absolute values and inequalities, use absolute values and inequalities to solve problems. So this is like the general idea of what the book is having us do for today. We had the vocabulary, discussion, and classwork. So review vocabulary. Absolute value should be a review term for you, so you should have seen it, but that's perfectly fine. We were just dealing with compound inequality, so that should be fine. Solution to an equation, solution to an inequality. So those are the only ones that are kind of different. So we have solution to inequality, doing that, equation, we've been doing that, compound, doing that. This is the only one that might be a little bit fuzzy. So let's go have a look at that. So the absolute value rules. Absolute value is a function that measures distance, any number, whole or part. So decimals are okay, and it's going to be from 0. About that, distance is always positive. You can't really go a negative distance. So think about a washing machine. You put in dirty laundry, a negative number, and it comes out clean, positive. So these are just some of the general rules regarding absolute values, and we'll see about that in a bit. So simple example, how far are these from 0? 3. The absolute value of 3 and the absolute is 3. What about the absolute value of -10? -10, even if it's negative, it's still 10 units away from 0. So 10. Pretty simple. So we also have a checklist. This checklist coming up here might be important to write down. So it's just kind of like the case method with the infinite solutions, no solutions. This is similar. So checklist, evaluate. We're assuming the variable x is inside the absolute value. As you see, there's an example, x plus 1 is 3. Is the function isolated and positive? As you see here, there's nothing multiplied here. There's nothing subtracted on this side. The absolute value x function, which is the absolute value of x plus 1, is isolated on one side, and the result over here is positive. If yes, you drop the absolute value signs and solve for the very first answer. First answer. There are two answers with absolute values. For the second answer, you need to change the sign of everything outside the absolute value and drop the absolute value again to get the second answer. For instance, you would have a -3 instead of a +3. We'll see that in a little bit, all right? All right. You might have a case where it's not isolated, like B. Example is we have that multiplication of 3 times the absolute value function. So we need to take care of that 3 first. So we would have to divide both sides by 3 before we can get back to case A, or basically checklist A, and go through that checklist. So you isolate the function, drop back up in C2A and 2C, or 1A, 1C. It's supposed to be 1, sorry. I did some odd edits, so 1A, 1C. So once you isolate the function, you check. Is it positive? Yes, go through this. Is it negative or not positive, like this case? No solution. So you see that you can have negatives inside here, but as soon as they're over here and you can't do any more isolation, that's when you're going to run into a problem. And that's when it's going to be no solution. But if it has a solution and you have an x inside the absolute value symbol, then you have two solutions. But if you don't have an x inside, like we saw with the two easy examples, you only have one solution. All right, so let's go ahead and put this to work. So we're going to start nice and simple. So again, see we have that -4. That's perfectly allowed. So for our very first solution, we're going to drop the sign, the absolute value function, so the two lines, and write everything as is. So let's just go and do that. X minus 4 is equal to 9. Well, that's pretty simple. We need to isolate the x, so we need to add 4 to both sides. We're going to go ahead and cancel on the one side, and then we're going to simplify 9 plus 4, getting us 13. That is our first answer. Now we need to, again, write everything as is on the inside, but we have to change everything that's outside. Notice I purposely made this red. I made that equal sign red for a reason, because if it was an inequality, we would have to flip that sign. So there's a reason I made that red. If it's an equality, flip the sign. We're basically essentially multiplying this whole part right here by -1, or dividing by -1. Anyways, you'll see that we are doing the same kind of steps. We're going to add 4 to both sides, cancel the -4 with the +4, and then simplify. So if you're not entirely sold that these two are the solutions, let's go ahead and do a quick check. So we're going to bring that -4 down, and we're hoping to get to a 9. So we're hoping to get to a positive or -9. 13 minus 4, well, that's going to get us a 9. And -5, -4, both negative, so they add -9. Both 9 and -9 are 9 units away from 0, so they're both solutions. So we would display the answer like this with the curly braces. All right, let's carry on. So a more complex example is more complex example, 1 isolate stage. So like this is the first thing we need to do is isolate. We're in the first stage of isolation. That's what this means. More complex example, isolation stage, stage 1. So notice we have this -4 and -28. Some of you might be tempted to say, no solution. But this isn't isolated. We first need to isolate this before we can say no solution. That means we have to divide everything by that -4. So bring down the -4. And we'll see that, well, we can cancel first, -4 divided by -4. And then we're going to simplify. -28 divided by -4 gets us a 7. So notice that we have x plus 3 is equal to 7. We're isolated and positive, so we can have two solutions. So let's go and look at them. So we have x plus 3 is equal to 7. Again, first one's pretty easy. We write everything out exactly as is. So x plus 3 is equal to 7. Subtract the 3 from both sides. So we're going to cancel and then reduce. 7 minus 3 is 4. That's our first solution. So now we need to go ahead and bring over that -7. And you saw how that was an equal sign was red. Just as a reminder, inequality, flip the sign. Okay. So now we need to subtract 3 from both sides. Cancel. Simplify. -10. So if you're tired of performing the same exact operations in the steps, so you see right here, -3, -3, -3, -3. And if we had anything to divide, we would have done that next. For example 3, we're going to have a more advanced step, but for right now, we need to write the answer, which is at -10, -4. So just know that's example 3. So we're going to have another example example 2, where we're going to go ahead and go through this longer route, but there is more of a way you can go about this, but you need to know about what you're doing. All right. So let's have a look at example 2. As you see, we have dividing inside, but we're also subtracting on the outside. So we need to take care of that first to see if we can do anything. So we're going to add 4 to both sides. And by adding 4, we can cancel, then simplify. You get x divided by 5 is 2. That's perfectly allowed. So we have two solutions. Bring it on up. X divided by 5 is 2. What we're going to do is write the first one over here and realize the only thing we really need to do is get rid of this divisor of 5. To do that, we're going to multiply by 5. Okay? We then distribute that 5. 5 divided by 5 makes it so we can cancel the 5 and simplify to get 10. So now we're going to go ahead and solve for the other answer over here. You're going to see that this is going to be very simple and similar to our first answer because we're just going to do the same exact steps. Multiply by 5, distribute the 5. If you have to do the step, you can, but if you just know 5 divided by 5 will get you here, like 5 divided by 5 gets you here, 5 times 2 gets you here, go there. So this is more like an in-between step if you actually need it. You don't have to do this step technically, you just know that you're distributing. So x equals 5 times negative 2 or negative 10. So the answer is going to be negative 10, 10. And does that make sense? Well, negative 10 divided by 5 is going to get us a negative 2, an absolute value of negative 2 works. Same with 10. All right. So this is another method. You can solve both at once, but first things first is we have to isolate. We have a negative symbol and a plus 10. So we're multiplying by a negative 1 and we're adding 10. We need to take care of that first. So let's go ahead and subtract the 10 from both sides. So that's going to temporarily put us into a case where we have a negative on one side, as you see. But now we can actually say, hey, we have to get rid of that negative symbol, so we have to multiply everything by that negative 1. Distributing that negative 1 through. And we have a positive isolated 5 plus 4x, no negative sign out front of it anymore. And canceling or simplifying on the other side, we have a 1. So we know we have at least 2 solutions. Later on in mathematics, you'll say this solution makes no sense. We don't need it. Disregard it. So instead of solving one, then solving the other, let's prep both at the same exact time. So write everything as is and bring down that negative 1 on the other one. Now, what do we need to do to this equation? Notice that it's the same thing. We're adding 5, we're multiplying by 4. So we're going to have to at least subtract 5 at one point and divide by 4 at one point. Okay? Same goes for this one. Adding 5, multiplying by 4. Subtract 5, divide by 4. So let's just go and move the 5 over. So we're just going to subtract the 5 right there. And right next to it, we can also subtract the 5 right over there. Same step, same thing. So canceling on both sides. And then we simplify on both sides. So we'll have 4x is equal to negative 4 and 4x is equal to negative 6. Last step is we just have to divide everything by 4. That way we can cancel and simplify, which we can also reduce over there. So our actual answer will be negative 1, negative 3 halves. So you might not be entirely sold on that. That's why there's that question mark. So this is just the process. As you saw, we went through, and what we did to one, we did to the other, just to double check. So let's go ahead and have a look at this answer and see if it actually checks out. All right. So we're going to take a moment, give you guys a moment to write this down if you need to, but then we're going to take this, move it on, check. All right. So looking at this answer, you might not be sold on it. So let's bring down and do a quick check. We're going to check with the negative 1 first, and we're going to check the negative 3 halves over here. So negative 1, negative 3 halves. Bring the negative 1 in. So it's going to be 5 times 4 times that negative 1 plus 10, or absolute value. It's going to take the opposite of that, then go from there. Notice we have no x anymore, so we can just evaluate like any other equation. You can consider this kind of like inside parentheses and evaluate this first. Get this isolated first, and then take the absolute value of it, take the opposite sign of it, and go from there. So that's what we're going to do. So 4 times a negative 1 will get us a negative 4. 5 minus 4 gets us a 1. And the absolute value of 1, that's 1 unit away from 0, so we would put 1. But now we have to multiply by that negative 1, getting us a negative 1 plus 10. And we simplify, we get 9 equals 9. All right, so 9 equals 9, that's a true statement. That means negative 1 definitely checks out as a solution. So let's go ahead and plug in the 3 halves. All right, and we're going to do that over here. So it's going to be a ring in a negative 3 halves, and we're going to have negative 5 plus 4 times negative 3 halves plus 10, the absolute value. So we need to evaluate what's on the inside first. So we can see we're left with 2. So 5 plus 2 times negative 3. All right. Well, 2 times negative 3 gets us a negative 6. 5 minus 6 gives us a negative 1. And the absolute value of negative 1 is still 1 unit away from 0, gets us 1. Notice right there, we're in the same exact step, which means we're going to have the same exact step to follow. And lo and behold, we'll get the same exact answer. So that is, in fact, the answer we are after. All right. So it's pretty easy today. We're just going through getting an understanding of this today. We have the equal signs. We're not going to be graphing today, but we're going tomorrow or on Friday we're going to change this out for an absolute value sign, not absolute value, sorry, inequality sign, greater than, less than. So it's going to be looking at graphing like that. Have a nice one.